In part 2 of this unit, we are talking about negative and zero exponents. So in part 1, we talked about the product of powers property and the quotient of powers property. Now we're going to look at when we have negative exponents and when we have zero exponents. So again, I copied this out of the book. It's kind of hard to read on the video. It should be a lot easier to read on your note page. So the first thing, for any non-zero number, if we take it to the zero power, it's going to equal 1. Okay? Regardless of what it is, if it's a number, variable, whatever, if we go to the zero power, it's going to be 1. Now again, it's important to remember that this only goes with the number that's out, or the whatever's right in front of it. So if I have 2x to the 0 only goes to the x. So I technically have 2 times 1, which is 2. So the exponent only goes with whatever's directly in front. So that's pretty straightforward. The negative exponents is a little bit more difficult. So say I had 4 to the negative second, and I want to write that with positive exponents only. I would rewrite that as 1 over 4 to the positive second. So I have it to the negative, I rewrite it with a positive exponent. Same thing with the variable. So say I have y to the negative 4th, I can rewrite that as 1 over y to the positive. All right, so let's look at a couple examples. It says powers with negative and zero exponents. Write the expression using only positive exponents. So it's important to read the directions for these. We only want positive exponents. So I have 7 to the negative 5th, so I'm going to rewrite that as 1 over 7 to the positive 5th. That's my negative rule. For number 2, I have 137 to the 0 power, which are rules that just becomes 1. For 13, we have 14g to the negative 8. Again, remember, the negative 8 only goes with the g. So I have 14 times 1 over g to the positive 8. That's how I rewrite even the negative 8. Now I need to keep going though because I'm not done. So I can just multiply. This is technically 14 over 1. So I get 14 over g to the positive 8. And that would be my final simple fraction. For number 4, I have a to the negative 7th and b to the positive 3rd. So I need to start by rewriting a to the negative 7th as 1 over a to the positive 7th. And multiply that by b to the 3rd. I can rewrite this over 1, so that means I'll have b to the 3rd over a to the 7th when I multiply those out. If you look at the next section, it says write the expression without using a fraction bar. So this is basically the opposite of what we just did. Now, this is going to be kind of hard to remember, but when I have something like 1 over 16, remember, we're working with exponents. Right now, I don't have an exponent. So what I need to do is take a factor tree for 16. So if I was to factor that, I get 4 and 4 and 2 and 2. So that's my factor tree. My prime factorization is 2 over 4. So what I'm saying then is that 1 over 16 I can rewrite as 1 over 2 to the 4th. Now the directions ask me to write this without a fraction bar. So if you think about our negative rules, I'm basically undoing that negative rule, and I'll get 2 to the negative 4th as my answer. So if I have a positive on the bottom of a fraction, I want to get rid of that fraction bar, I have to write it as negative. So looking at number 2 then, I have h to the positive 4th on the bottom, so to get rid of that fraction bar, that 4 has to become negative. If you look at number 3, I have 8d to the 3rd on the top and e to the 7th on the bottom. So 8d to the 3rd can stay how it is, because it's already on top. Now I need to move e to the 7th to the top, so I have to make that 7 negative. So we're basically undoing the negative rule of exponents. If you look at the bottom of the page, it says using power properties with negative exponents. So we're looking at the product property and the quotient property. So for number 1, we have 9 to the negative 5th times 9 to the 6. Again, it's kind of, or 9 to the negative 6, sorry. It's kind of hard to read on the video, but this is how it looks on your book. So we're going to start by using the power property, meaning I can just add these exponents together, and that'll give me 9 to the negative 11. Now, if you look at your directions, it says write using only positive exponents. So I need to use my negative rule here. So that means this is going to turn into 1 over 9 to the positive 11 in my final answer. For number 2, I have b to the negative 10 times b to the 6. It's hard to read on the video. So I have the same base, so I can add these together. Negative 10 plus 6 is negative 4. I only want positive exponents, so I'm going to rewrite this 1 over b to the positive 4. And I'll be done here. Number 3 gets a little bit tricky because we have a lot going on. But I can start by multiplying my coefficients together because they do not have exponents with them. So I can start by doing 3 times 8. And then I have s, and I can add my exponents. So I have 0 plus negative 5. So when I work that out, I get 24s to the negative 6. Now I'm not done because I don't have positive exponents. So I need to move this negative 6 to the bottom so it becomes positive. Notice that the 24 stays on the top. This 24 is going to count 3 exponents. Another way you can think of that is s to the 0 would just be 1. So you wouldn't even have to worry about adding to this. Looking at 4, 5, and 6, now we're dealing with the quotient property. Okay, so reminder for the quotient property, if you have a common base, you're going to subtract those exponents. So looking at this first example, I have 5, and then I'm going to do 6 minus 12. We always do the numerator exponent minus the denominator exponent. When I subtract those, though, I wind up with a negative 6. We only want positive exponents, so I'm going to have to write this as a fraction and write that underneath 1. For number 5, we're going to start by simplifying the coefficient parts, and that's going to simplify down to 3 over 1, or just 3. So now I have 3h. I have negative 8 on the top, so I do negative 8 minus 2. When I work that out, I get negative 10. Now I need to make positive exponents, so 3 stays on the top, h to the positive 10 on the bottom. Looking at number 6, I'm going to start by simplifying the coefficient part, so I can reduce it down to 5 over 4. So I have 5 over 4, and then I have f to the negative second minus negative 14. F to the negative second minus 14. When I work that out, I get f to the 12, and since it's already positive, I can write it on the top. So I'll have 5f to the 12 over 4. And I'm done there. If I wound up with 5 over 4 f to the negative 12, I would have had to write the 12 on the bottom. Okay, so that would have been a little bit different there. Now, all these rules can get a bit confusing, so just ask me if you have any questions. If you flip over the back side, there's just a page full of review problems. Integer operations, least common multiple, various common factors. Please make sure you get this page done and graded. This is important stuff.